Okay, well, welcome back, Zebra Challengers. Here we have the reveal for challenge number 6. I'm going to do it in two parts because we had two parts to this challenge. The first was to make this two-way wall switch work. So if I would flip the panel, the switch on, the light would glow, and the wire would show connecting the two leads. When I turn it off, the light goes off. Okay? Now the solution here depends entirely on understanding checkboxes. Now a checkbox seems like it's just a way to make a check in a box, but you really want to think about these as a way to manage alternative states. The checkbox is a great way to have two different images that are displayed and controlled based on what the user has selected. And this is all based on the fact, if we look at this checkbox that I have here called switch, notice that there's a property called checked. Right now it's false. When I click the box, it becomes true. And each time I click, it alternates between true and false. So we can use that to drive all sorts of things. So let's say this is a switch checkbox and I have the bulb. I want the bulb to turn on whenever the switch is on. So if I just bind my checked value from the switch to the checked value on the bulb, now they both turn on whenever one is on, one's off. Okay. Similarly, we could draw the wire. I'll create a line here that's our wire. Okay, there's our wire. And whenever the checked value is true, I want this to be visible. When it's false, I want it to be hidden. So I can wire directly to visible. And now I get exactly the behavior that I needed for the for that switch. And now the cool thing about this is you generally don't want these checkboxes to look like a box with an X in it. But in our checkbox properties there's a graphic button area, and that allows you to put in graphic images for all the various states. And we actually only want two. The up state, or the up, over, down, power off, is going to be our off, and our up, over, down, power off checked is going to be the on state, if that makes sense. So I have my graphics here, and so I'm going to take the off graphic and hover, and that got loaded into all of them. And now I'm going to take the on state and put it in the checked place. Okay, now one thing that does is we have checkboxes by default are set to be fixed proportion, so I want to keep aspect ratio and take that to be false, so it'll have the ratio of the actual image. But notice now when I flip the switch, it's acting exactly like the checkbox did, but now it's doing it based on these two images. Now similarly, I can come over here to my bulb and put my two bulb states on. So there's the off state, and then when the bulb is turned on, again, go to geometry, make the aspect ratio. Now when I run it, everything works. So you can see how then to get our final product, you would put the background in and color your wire the right way. Now for the second part of the challenge. This may seem like it would be the exact same solution because it's a very similar sort of problem, but we actually have an interesting twist on this, because now we have a compound decision to make about whether the light is on or not. It isn't as simple as just tying it to one switch. Now it's based on a decision about both switches. So both switches have to be on for the light to be on, or both have to be off. Okay? The other situations have to be off, so we can't tie it checked to both because we have two different inputs. So we're going to use a new feature called truth table. Now a truth table allows you to make complex if-then-else sorts of decisions. Now here I have a new file that I have the switches already set. These are check boxes that have a left switch, a right switch, the bulb, and then I have the wires. So these are created just like we did in the first part. But now instead of wiring these directly, we're going to use what's called a truth table. And I'm going to use the truth table tool and click to create it. Now in this table, this allows us to attach multiple properties and then make a decision based on the status of those properties. So the inputs here are the checked value of my left switch. So I'm going to take checked, and I'm just going to wire it up here to where it says attach property. And notice now that's loaded in the gray part of this truth table. And I get a column 1 and 2, and so 1 corresponds to when checked is false, 1 corresponds to when checked is true. Now generally you're going to make a complex decision here, and so I'm going to now wire a second property from the right switch to the plus sign to add another line here. Notice as I do that, it expands the number of columns so that you have every possible combination of these two values. And you can see in each column, here's when both are false, here's when left is true and right is false, here's when left is false and right is true, and column 4 is when both are true. So that has given us a really nice table for us to categorize all the possible outcomes. Now generally you're going to show the outcomes by linking values, and over in our inspector, when we look at our truth table, there's an option on tables to show the value. So I'm going to turn that to true, and that expands our truth table to have a lower section where we can attach properties that are going to be set based on what combination of values exists at the top. Now first off, what I want to control is the light bulb. So I'm going to take my bulb checked and attach that here. Okay, so what this is saying is when I have both off, this is a value that's going to be set for bulb checked. And well, when both are off, I want this actually to be glowing. So I'm going to click here to change that to true. Now when one is off and one's on, then the light should be off, so that's false. But when both are turned on, I want that also to be true. Okay? So now this is my input part of it, and these are my outputs. When I run this, notice both are off, so the bulb is glowing. When I flip one on, it goes off. When I flip the other one on, it comes back on. And so now we have this behaving exactly as our logic statement would be, and it's done really quite simply by this truth table. Now you can add any number of additional elements to this. If you create too many inputs, the truth table gets too big, because you can imagine this grows exponentially. But 3 to 4, it's pretty easy to control the input of that number of objects. Now I also want to control the visibility of these little wires, so I'm going to add those properties to my values section. So all 4 of these I'll put on. Now, these just need to link to which one of these switches is. So when the left switch is off, I want off to be true, and I want this to be false. And when the right is off, then I want it off to be true, and there. Now when I want this one, this is true, and that is true. And here's the reverse. So this is true, and this one's true, and here we have true and true. Now you notice that each of these is tied directly to the value of the switch, so I could have bound those wires, except for the opposite ones. It'd be easy to say when left switch is on, then show left on. But you have to do the reverse for the left off wire, and so then it gets tricky, and that's why adding all these to the truth table makes it orderly and easy to put together. So now when I have all this set, when I do my flips, you see just the right wires, you see the bulbs turning on and off, and you see all your switches working appropriately. So it's amazingly powerful, the combination of using checkboxes and then the strength of making complex decisions on a multiple number of items using the truth table. So hope you got part of that. I encourage you to play more with that. These are some tools that are going to be just indispensable in making your Zebra projects come to life.